Alright, so we're down at the shop today, and we're going to do a quick CNC video, just how to get started on one of these Fanucs. Again, I got a lot of questions, a lot of new stuff's come up, and just kind of wanted to hit on all of it, and hopefully it'll help some folks out. Anyway, stay tuned. Okay, so basically what I'm going to show you here is how to back up your machine. You need either a DNC or a computer, something to get your serial output to your machine or from your machine. So right now we've got the machine homed, 0 referenced. We're at 0. We're going to set this to edit. This needs to be in edit mode. Okay, now we're going to go to the parameter page, and the secret is you actually want to hit EOB and output at the same time. As you can see, we're outputting. I already had this set up to receive, and we're receiving a file now. That'll back up all of your parameters. So basically that's going to output everything to the DNC. And then we're going to go in and do the diagnostics portion as well. Alright, so do diagnostics. We're going to go to diagnostics. We're on our diagnostics page, and you want to hit output start. And it's going to output all of those parameters to your DNC. Now we're done. This goes a lot quicker than the other one. Okay, so if you are in the situation where you're basically restoring your parameters, these are the machine builder parameters. You want to make sure that there's some data here. It shouldn't be all zeros unless you have a very basic machine. But basically the way that you get there is you basically go into parameter and you want to scroll to this 900. This is on the OM. These are all the machine builder setup directives. Basically tells it, does it have a 4th axis? Does it have 3 axis? Do you have the rigid tapping option, etc.? And it's not something you could just turn on. You do have to have support from the machine builder. But you want to make sure that all this data matches the way your machine was set up. This is a key step in getting a machine, especially if the battery's died on it, getting that running. Okay, so if you watch my older videos, this machine, I've had this for quite a while now, several years. Just kind of wanted to point out some of the mods that I've done to it. Basically, I just have cleaned the machine. I did go with a Kurt Vise. Typically, this is making PCB enclosures out of either 6061 or 7075 aluminum. And that's basically what my tool setup is for. And that's mainly what I run in this machine. That's what I got it for. And it's done really well. It kind of just sits down here in the shop, and when I need to run off a couple, it never fails pretty much just to work. Really the only modifications I've had to do to it, starting at the machine over here, we replaced some air cylinders in that tool pot section. Took a little bit of work to find replacements, but I got direct replacements, got all that fixed, and that tool changer has been working great for over a year now without any issues. This is a BT40 style machine, so another thing that I did is I got all new tool holders for the most part. It did come with a couple, but basically about everything in the machine right now is all new. I did a little bit of work on the drains. Let's see if we can get in here. So basically this machine has dual basically catch pans that are on wheels. The wheels roll out. You can basically roll these out. These are the chip pans and the coolant storage. Chips stay in the top, the coolant goes down in the bottom. Really simple system. At the very back there's actually a little flap that hangs down. I did have to modify that just a little bit just to keep coolant from dripping on the floor. I originally used like a soluble coolant. I am using and have been using the clear Blazer, I think it's Synergy, and that has worked really well in this machine and kept it really clean. And I haven't had to do a lot of cleaning. If you watch my other videos cleaning up the huge mess, because I don't run the machine every single day, coolant gets down in here and it gets all nasty. That Synergy has been really good about not getting nasty. And I've basically been running it through filtration and keeping it really clean. And you have to use RO water with that, which has not been a big deal. I've got another video on that, on reverse osmosis. I basically set up a little small system down here. It's a home shop, and I make my own water to put in the coolant. Up top, really haven't had to do a lot of spindle maintenance. Just basically keeping it clean. There's a pneumatic oiler up there for the drawbar that's in the spindle head. You just need to make sure that stays full. And initially I thought it was a problem because you can't really see it. It's kind of one of those maintenance items that's hidden up above that. But you really don't have to do that about once a year. Usually it's only about half drained out every year that I change it. But it's behind that, and it's just a big plastic column with a cap on the top, and you basically make sure that does not get empty. When I did get the machine, I did pull a lot of this off and just clean out everything. I don't expect that it's super gummed up at this point because I've mainly been running aluminum, and most of the aluminum actually ends up slinging all the way out to the side with most of my cutters and down. I really don't have a whole lot of debris that actually gets up on the chip tray. When I run steel or run something slower, depending on the cutting, some of that stuff does kind of get in this area, but all my wave covers are intact. Pretty much the machine came that way. I didn't have to do a lot of work on the wave covers. So that's something important. You want to make sure that you keep those in good shape to keep chips out of places they're not supposed to be. Another mod that I did, completely changed out the cooling fluid nozzles. I went with this system. Basically it had just a cast iron pipe thing and a little maybe one of these little nozzles that they had added. This has worked a lot better. Basically I can kind of set those nozzles up to no matter what tool loads out of that, I will get some coolant running in the job. Up front here, really didn't have to do a whole lot. I really wish I could find a replacement button for this. This did have I think a yellow cap over it, and it has since broken off. I haven't really found a direct replacement for these. Mine, I don't have the key for this, but it's already an unlock. It's not a big deal to hot wire it. You can basically get to the back of this panel very easily, but I would have liked to have sourced new switches, mainly to replace this switch and have the proper color to tell you when the ATC is ready to be changed. I did put on a new membrane. These are available on eBay. You can pick those up. Also a new membrane here, brand new. Highly recommend you do that. It saves on these switches. This basically covers a switch module that's back here, and you see a lot of them, and this one too was kind of wore out and it was almost exposing the switch or had a hole. And I think I paid $9 for a brand new membrane cover. They're really easy to put on, and that's worked out really well. It's basically kept this nice and clean, kept this machine in good shape. There's probably the best example. This is a yellow, but it's orange, and it would be down here. So if anyone knows where to source these switches, really it doesn't have to be the same switch. It just needs to fit the same pattern and same connection on the back. But if you know where to source with one of those switches, either shoot me an email. The email is not really hard to find, or drop me a comment in this video. As far as some of the options my machine did not come with, auto power off I guess was an option, and program restart. This probably is pretty easy to add. I would basically just have to run a wire to the back to actually connect that up. It's in the ladder already. The feature's not turned on, but you could turn it on. You could put a switch here. I really don't use it because generally I'm drip feeding, and there's really no way to restart a program that you're drip feeding. If you notice here up front, I've got a whole video on this. This screen is all beautiful, and unlike most other OMs, it is in color. So this, I've done the LCD replacement. That has worked out really well. It fit really well. It's a much smaller part. And I don't know if it's going to come through on video or not, but this is like super sharp, really easy to read. what's going on. Just kind of flip between screens here. But really happy with this, with that upgrade. So if you do get one of these older machines and you can find an LCD replacement option, if it's got an old CRT in it, highly recommend it. It really kind of, you know, changes the machine a little bit. It makes it a little bit easier to use. Okay, so one of the biggest things, especially on a parameter loss, yes, you are going to have to find someone that has the parameters for your machine. Yes, you're probably going to have to mess with those parameters because there's things like backlash control. There's some servo stuff that is specific to your particular machine. It's basically a tuning option, and you may have to mess with those. Once you get there, what a lot of people have trouble with is the tool changer. So on my particular machine, I will show you basically what it has in it. Is it has basically a macro. If you can see up here, this is the previous operator that had it. They actually had this set to M66, which I think is a 240 plus option in the parameter. So all it really does is when you execute an M66, it will actually run a 9000 series program that you have stored, a macro, to execute a tool change program. And let me kind of explain what that means. So basically you have the column here. Right now we're at the home position. So this column is actually too high or maybe too low. And it's pretty close. It moves just a little bit. But this column has to be in a particular position for that tool changer to grab that. Also the spindle, as you can see there, the tang on the spindle is not aligned with this. So the spindle needs to be rotated. And this machine has a particular place for the Z height on the column and the spindle rotation to make that tool changer work. The tool changer will not kick out and work. You can kind of tell it here because the ATC light is not on. If you can't get the spindle in a position for this to work, you're not going to get a tool change. So there's a couple of different ways of going about it. The way I did my machine is I basically went initially into MDI mode and verified. Luckily I had the machine manual which described the tool change commands. So I did that in MDI mode until I got this ATC light to turn on. Once that ATC light turned on, I took that program and just did a program. I'm going to show it to you here. Luckily I still had it in the DNC and I just pulled it up to the machine. So this is kind of an example here. So it's basically doing a G91, G0, G30, Z0, M19, Tool 6, M6. So basically this command here is orienting where that actually needs to be. Then it's executing an M19. Then it actually does the tool number 6 and runs the M6 command to change the tool. So all the macro does is basically when you run an M6 command, it basically does this and it replaces this tool 06 with a variable of the tool that you typed in originally in your program. You can do this multiple ways. For a long time I actually just added this code into my post processor before I did the macro. That works the same. The only difference is if I generate a program here and I use the program somewhere else, you cannot, this doesn't work on every machine. So to make it standard, I did end up setting up the macro. You can go into the 240 parameter settings and set a bit or a value there to tell it which M6, M7, M66, whatever you want to do here to execute, like program 9001, 9002, 9003, 9004, etc. So that's a little bit of flexibility. You can kind of do some cool things with that as well as with a Heimer. I eventually did a tool command just for the Heimer, just to set the work offset so I could read the positional information that was here and not have to do this. So this is the offset for basically my gauge line setup, which isn't a true gauge line. Basically I'm just using the bottom of the spindle. But the tooling and everything all sit in this machine, so it really isn't an issue. If you have multiple machines, you actually need to use a proper gauge line. So I'm just going to get you another screenshot of that just to let you look and kind of see how that works. So basically, this is actually two changes. So if you ignore that part and look at that, that is basically how to do a tool change on this particular Excel machine. And a lot of other machines are going to be similar. And this is just another tool change. So we'll let this run here. So we've got it on run. So you saw it oriented the spindle. Tool change light is on, now it's off. And we're going to be in tool change. Okay, so it got done with that tool change. We just ran it. It kept the position for the tool change, so our ATC is on. If we go here and we basically reorient things, this is really hard to do holding the camera at the same time. So we got our Z. Well, I had my incremental set, but you can see it that immediately went off. I'm going to actually move the Z quite a bit. I'm going to move that Z way down so that you can kind of see what this program is going to do. So the spindle orientation is probably relatively close. It's probably still going to turn it from this command, but I'm just going to let you see what this looks like. So we're going to go back to auto, make sure your cursor's up at the top of the program, and we're going to run this program. So I'm going to kind of just move over here right before I hit the green button. And there's a tool change. Now we look back down here. That's reoriented and this light's on. So that's what you're looking for if you're trying to get your machine at least to do a tool change, especially if it's new, you've never used a Fanuc controller before. And this is going to be similar for other machines as well. You really need to get this working first, and what you're looking for is, does the machine look like it's in the tool change position? It's not just going to magically change tools. Some machines have this integrated. They have an external PMC that basically does this outside of the Fanuc control. On these more common machines, this is all integrated into the control itself, and the machine builders elected to basically make this a manual process or a macro process, what have you, to be put into post or be put into a macro. And my machine does have the macro option, so that is a benefit in its own. Okay, so I'm going to go over this just for consistency. This is if you got a machine, you don't know anything about one of these, you're trying to get started. I get a lot of comments and questions. This is something that is not necessarily intuitive, and I find myself, even if especially if I've kind of took a month break or so, you just forget things. So the way you zero reference one of these Fanucs is you basically go to the zero reference setting. And what gets a lot of people is they think it's a cycle start. It's not. You go to zero reference setting, and you actually have to do each axis individually. And the way you do it is you basically do X, Y, and Z. And it will actually, the machine's smart enough to basically queue that stuff up, and it will cycle everything. Right now we're already zero referenced. I'll kind of give you an example here. So we're going to take everything out of reference here. Okay, so this machine is not like, uber fast, but it's pretty quick. So I've got this full speed, as fast as this machine will go, to do a zero reference, and I'm going to do these sequentially. So we're going to do X first, Y, and Z. My hand's up here, and I've already executed everything, so it's going to do those in order sequentially. And now the machine is back to home position. Okay, so this is a more advanced topic. There's a million different ways of doing this. This is my offset table. So if you look at if you want a proven method You can basically use the gauge line method, but not using the gauge line, just using the bottom of the spindle. Basically, I set a known height measurement tool down on the deck, bring the tool down, touch it. I've got my gauge line, I did a little bit of math, and my whole machine is set up for positive work offsets. You can do that, or you can do something else. To basically be able to get your work offsets, you go here, and you can see my G54 is set to 0 right now. I have a couple other jobs that I was running prior that I was actually using the other work offsets. And then you have this shift function. So always make sure that's 0. I have used this some, doing some odd parts, basically where I'm shifting my standard work offset because I have a known offset in the vise. But that's how you get to that. I recommend picking one of these. It really doesn't matter which method you use. There's gauge line, there's, you know, you can actually offset off of the work part. You can offset off of the vise. But pick one and stick with it. Get all your tooling set up. I have I've started exporting all this data out into Fusion. At some date in the future, I may just stop taking it on the machine and actually leave it in Fusion. And that's mainly because it's not super difficult to enter a work offset here, but it is definitely easier to enter work offset in Fusion because it's, you know, a computer and it's got a keyboard versus having to type this in and, you know, using all the command set to actually get data in here. And basically the way this works is you will alter one of these settings and then accept it as input. So I'm just going to go through and kind of show you what these menu options are. Your machine may be different. So you got your positional screen. You can go to all, relational, or absolute. So this is what I did this morning. We ran 20 parts. The first one didn't kind of pan out. Really short run time. I usually do reset this. You can reset this from the parameter screen. I think you may be able to reset it from the actual positional screen. I don't remember. But you can reset this every time you use the machine. You can either do just the cycle time or the run time. I usually do both, just so I can write it down on this batch. Kind of what it looked like. Okay, so now we're at the back of the machine. I apologize for the audio. There's really not a great solution for this because it's loud back here and I'm in a little enclosed space. So we'll do the best that we can to describe this. So back here on my machine, it's running. You don't want to stick your fingers in anything. You can kind of see here, let's see. Okay, so if you notice this breaker, the colors are different. When you first hook one of these machines up, they're 3-phase, and you may need to swap a leg to get your rotations right. So what I highly recommend to get your rotations right, generally the coolant pump is just a motor that spins and it won't hurt it to run backwards. So when you first hook up a machine, before you do a tool change or anything, check that coolant pump, make sure it's turning the right direction. If it's not, you need to flip the whole machine before you try to do a tool change. My tool changer, it will run backwards, but it gets locked up. So just a kind of a tip there, speaking from experience. So shipping wise, when this machine came to me, I immediately had a servo error. I had seen the machine running video, so I knew something had happened during shipping. So what it actually ended up being was this optical cable here had actually came loose. So you've got an optical cable that runs up, around, and into one of the other boards. Check that. These are really bad to just kind of pop loose from vibration. These are not so bad. They basically have screws that set them in. This one doesn't have anything except for just a little bit of retention. It has a little tab. Be real careful. It's optical. You don't want to get the end of it dirty. So this right here is what your servo controller is going to look like. So if your servo is not working, check this, see what your display says. You know, check the lights. There is a couple of things you can do here. There's actually options in this that you can actually get to from here. I've never had to do that. As far as like programming and stuff, generally, let's see. My machine, I believe, has the PMC or the ladder is actually an EEPROM, so that can't be deleted. The only thing you don't want to do is pull one of these labels off, because the EEPROM works off UV light, so you don't want to expose it to light. So don't go peeling off labels off of chips, because you'll actually end up erasing your program. One thing I love about this machine is it's nicely laid out. I do have the electrical diagram, and it has lighted relays, and they're all positioned kind of in a way that makes sense to see if something is wrong. That's kind of how I discovered the pneumatic cylinder that was causing trouble. It actually wasn't pushing the cylinder exactly where it needed to be, and the light wasn't coming on, so it was really easy to diagnose. Another thing that I'll mention, if your machine gets out of whack, check these resets. You need to be real careful. This is you know, 3-phase 240 power back here. And another thing is, these are contactors, and these are for the tool changer, and I have had to manually push the contactor to get the tool changer kind of out of whack. Basically it couldn't correct itself, so I had to do something to correct the issue. So this would be servo. This should be axis control, I believe. So I think for this machine there is a 4th axis module that is basically a smaller card than this that you could actually add to the machine if you wanted to. I've been real lucky. My machine's set up for basically any voltage that I could think of. You would change that here, and here's where you check it to make sure you match voltage before you hook the machine up. I am running this machine on an American rotary converter. And this basically is the brains of the unit. You can tell a lot by what's hooked up here, what options your machine have, which blades you have in there. My machine does not have the graphical display, etc. And all that's really easy to find out here. One thing that causes a lot of people grief is this PSU unit. This is a power supply. These are fairly delicate, and I have not had to replace mine, but in some other machines that I've ran, this is usually the culprit, or what goes out first, in my experience. Okay, so now we're going to talk about the main thing that happens with these older machines. People don't change the batteries. So basically, this is in a hobby shop. It's not powered all the time. It's hooked up to that American rotary there. Actually, let me correct an issue here before we get started. We are on. So that basically engages a breaker behind the door, and I wasn't careful when I shut it to make sure that it actually latched on the breaker, but we're good now. So this machine's on right now. The machine does need to be on. It needs to be running. Check your display, look for low battery alert. Have the machine running before you touch this battery. So basically you want to swap this battery out without a power loss, without powering down the machine, etc. Because if you take these batteries out with the machine unpowered, you'll lose all your settings. So this is where the batteries are at on mine. They're D batteries. I change mine out every year, but they probably will last years. So you're talking about something you just kind of keep an eye on. And it does give you a warning on the display when those batteries are getting low. So this is the coolant pump. That's what it looks like. I kind of pulled it out to show you that you can kind of pull my coolant pump out and look at the bottom. It was too heavy to pick up and turn around, but there's an impeller on the bottom of it. It's really easy to see whether it's turning the right direction. But that relates back to the, getting your phases correct coming in the machine. Okay, that closes out this video. Hopefully that answered some questions. If you do end up buying one of these used Fanucs, hopefully that helps you out kind of in a direction to get you going. Some good resources is Practical Machinist, CNC Forum, etc. A lot of those forums have a lot of information. A lot of it's older information because you know, these machines are getting fewer and fewer, and it's a little harder to find out information about them. I've had this machine for several years now. It's really done well. It's definitely paid for itself. And I'm really happy that I got it. It was a little bit of a struggle when I first got it to kind of, you know, learn everything about this particular machine. Resolved the very few issues that I had. Really, the only tough one was that pneumatic cylinder in the back. When I did purchase that cylinder, I bought the other cylinder as well. I've got it back there in the box for when or if it fails. So there's two, one for the pop push and the other for the slider. I only replaced the one that was bad. But anyway, hope this helps out, and we'll see you on the next one. Be sure to drop a comment if you've got one of these machines and have some expertise or pointers that may help someone out. Be sure to drop a comment. If you're still looking for help, you know, drop a comment. I'll try to do what I can to help. A lot of folks end up getting these and they don't have any documentation or any manuals. So it's kind of, you know, one of those things where you're going to have to get that really first to really start working on the machine. Thanks, and we'll see you on the next one.